the last property well, that's not really a property of all real numbers. I guess it depends on the situation, but it's my favorite, and it is called the closure property. And it's kind of hard to explain, but it's a lot easier to show. So, to give examples, so I could say the rational numbers. All right, this is all the rational numbers. Oh, wait, no, that's the real numbers. Sorry. Yeah, this works for the real numbers too. The real numbers are closed under addition. All right? And the reason that this is true is because if you take any real number that you can think of, all right? So think of any real number, this is A, and add to it another real number. The question is, do you always get another real number? And that's true. Yeah, if you add two real numbers, you will get another real number. Instead of the real numbers, let's look at it for a specific one. How about the natural numbers? All right. So if you take two natural numbers and you multiply them, if you take two natural numbers, this is from 1, 2, 3. This is all those whole numbers after 0. If you take any two natural numbers, so natural number 1 and natural number 2, do you always get another natural number? And the answer is yes. Yeah, you always do. 5 times 2, that is 10, and 10's a natural number. Let's say we were asking the question about division. All right, and this is a pretty easy. You can, if you understand what I mean by closed or closure, you'll know the answer to this pretty quick. But do the natural numbers, do they show closure under division? So if you take two natural numbers and divide them, do you always get a natural number? And the answer is no. It might work out for 10 divided by 2. That's a natural number. Those are all natural numbers. But if you take 10 divided by 3, you don't wind up with a natural number. You wind up with a rational number. Or, whatever. Q is for the rational numbers. But you don't get another natural number. And that's a property that people talk about. Are the prime numbers, you remember, 2, 3, 5, 7? You could ask the same questions about those. One last example here, just so you have plenty. But the question is, are the irrational numbers closed under let's do division. All right, are they closed under division? And the answer is no. All right, so what this means, if they were closed under division, it would mean that an irrational number divided by an irrational number is always irrational. But here's whenever it's not. Pi divided by pi. What does that equal? 1. And 1 is not irrational. All right? Let's say you thought they were closed under multiplication. Are the irrational numbers closed under multiplication? No, they are not. Because if you take the square root of 2 and times it by the square root of 2, you get the square root of 4, which is 2. You took two irrational numbers and multiplied them and got a rational number. That means that the irrational numbers are not closed.